Hi guys, welcome to today's tutorial. Today we'll be treating on trigonometry ratios of special angles. Alright, now going right into it, angles such as 30 degrees, 45 degrees and 60 degrees are called special angles. Why? Because these angles can be gotten or calculated from our equilateral triangle and our right angled triangle. Now, how can we calculate 30 degrees, 45 degrees and 60 degrees from this triangle? Now, looking at an equilateral triangle, we know that an equilateral triangle is a triangle in which sides, all sides are equal. Okay, and for our right angle triangle, we assume that these both sides are equal, which we assume to be 1. Now, first, let's calculate for 30 degrees and 60 degrees from our equilateral triangle. Now, from this triangle, if we draw a line coming down here, we know that for an equilateral triangle, all angles are at 60 degrees. So if we draw a line that bisects this, okay, forming a right angle here, this becomes 30 to form 60 degrees. Now, bear in mind also that for every right angle, for every triangle is 90 degrees. So if we look at this portion, we're having 90, 30, 60, which is 180 degrees. 90, 30, 60 on the other side, which is 180 degrees, also goes to prove that sum of angles in a triangle is 180 degrees. Now, so for this, since it's being shared, this will become 1, 1. Alright, let's draw out a portion of this triangle. If we have a portion of this triangle as this, 30 and 60, okay, this is our hypotenuse 2. Our adjacent will be 1. Now we can find our opposite. Now, considering angle 60, okay, considering angle 60, okay, now this will come, we know that our SOHCAHTOA, okay, and now since we want to find the opposite, we are going to use our Pythagoras theorem, which says hypotenuse squared equals opposite squared plus adjacent squared. Now these two formulas will be helpful in solving out this triangle. Now let's calculate our adjacent using Pythagoras theorem. Now we know that our hypotenuse squared is 2 squared equals opposite, we do not know, x plus adjacent 1 squared. So this will be 4 squared, 4, 2 times 2, 4, equals x plus 1. So our x squared equals 4 minus 1. So our x equals root 3. So our opposite here will become root 3. Alright, now having calculated our opposite to be root 3, we can now say, considering 60 degrees, alright, considering this 60 degrees as our adjacent, alright, now this will become sine, our sine 60 will become opposite over hypotenuse. Opposite is root 3 over hypotenuse, which is 2. Okay, now tan cos 60 is going to become adjacent over hypotenuse, which is 1 over 2. And tan 60 will become adjacent over opposite over adjacent, which is root 3 over 1, which gives us root 3. Alright, now for considering 30 and sine 30, our sine 30 will become, now if we consider angle 30, root 3 becomes our opposite adjacent, 1 becomes our opposite, and 2 will still be our hypotenuse. So considering angle 30, alright, now this will become opposite over hypotenuse. Opposite over hypotenuse is 1 over 2. Okay, sin 30 will give us 1 over 2. Now, cos 30 would give us, cos 30 is adjacent over hypotenuse. Adjacent is root 3, hypotenuse is 2. Cos 30 will give us root 3 over 2. And tan 30 will give us tan 30, which is opposite over adjacent, 1 over root 3. 1 over root 3. Now, if we rationalize 1 over root 3, we are going to have it as 1 over root 3 times root 3 over root 3, okay, which will eventually give us root 3 over 3. Okay, so for sin 60, we have it as root 3 over 2. Cos 60, we have it as 1 over 2. Tan 60, we have it as root 3. Sin 30, we have it as half. Cos 30, we have it as 2 root 3 over 2. And tan 30, we have it as root 3 over 3. Now, this is how you calculate your 30 and 60 degrees using your triangle, your equilateral triangle. Now, looking at this for 45, angle 45, which is our next special angle. Okay, now we have to find our hypotenuse. So for us to get our hypotenuse, we see apply a Pythagoras theorem, which says 1 squared plus 1 squared equals our hypotenuse squared. So this becomes our hypotenuse will give us root 2. So our hypotenuse will become root 2. Alright, now bearing in mind now that our hypotenuse is root 2, okay, we can now calculate sine 45 will become opposite, okay, considering any of these sides. Okay, so let's use this as our opposite and this as our adjacent, since they are both same figures. Alright, so either ways you still get same answer. So opposite over hypotenuse will give us 1 over root 2. So if we rationalize this, this becomes 1 over root 2 times root 2 over root 2, which gives us root 2 over 2. Okay? Now, our next one says cos 45, which is adjacent over hypotenuse. So adjacent over hypotenuse will become 1 over root 2, which gives us root 2 over 2. And our tan 45, which will become opposite over adjacent, which is 1 over 1, which is 1. So with this, we've been able to find our special angles for 30, 45, and 60. So always bear in mind that for your 30 and 60, you use your right and equilateral triangles to calculate that, and for your 45 degrees, you use your 90 right angle triangle for that. Our first question says, without using table or calculators, find the value of sine squared 135 degrees. Okay, 1 minus sine squared 135 over 1 plus sine squared 135 degrees. Now, in doing this, for us to find our 135, we need to know what quadrant is our 135 degrees. Now, in trigonometry, a circle is divided into 4 parts, where we have our first quadrant, second quadrant, third quadrant, and fourth quadrant. Now, in each of these quadrants, all the signs, our sine, cosine, and tangent have different signs in this. Now, in this first quadrant, all three are positive. Okay, all three are positive in the first quadrant. In the second quadrant, only sine is positive. All right, in the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. So this forms our arc or cast. Okay, now since this is 135, bearing in mind that in first quadrant ranges 0 to 90, second quadrant ranges 90 to 180, third quadrant ranges from 180 to 270, and fourth quadrant ranges from 270 to 360. All right, now since 135 is in our second quadrant, we need to find the acute angle of 135. And in order to get the acute angle of 135, we'll be doing 180 minus theta. In this case, 135. So 180 minus 135 will give us a 45 degree. So our acute angle for 135 will be 45 degree. Now that we just saw earlier on, if we do sine 45 degrees from our special angles, okay, 1 root 2, 45, 45. Now if we do from our special angles, the value of sine 45 will give us 1 over root 2. Okay, now applying this to this becomes 1 minus sine square sine 1 over root 2 square all over 1 plus 1 over root 2 all squared. So solving this out, we are going to have 1 minus root 2 will cancel roots, root square will cancel our roots, 1 over 2 all over 1 plus 1 over 2. Now from here we are going to add up. 1 minus 1 over 2 will give us 1 over 2. 1 plus this will give us 3 over 2. Okay, now how did we get 3 over 2? Forming our LCM here, we have our LCM of 1 and 2 will be 2. This will be 2 plus 1 to give us 3 over 2 for our denominator. So from here, we can now do our multiplicative inverse to turn this division to multiplication, which will become 1 over 2 times 2 over 3. Okay, 2 cancels 2 to give us an answer as 1 over 3. So 1 over 3 is the value of 1 minus sine squared 135 degrees equal over 1 plus sine squared 135 degrees. If you've watched up to this moment and have enjoyed our lecture, don't forget to subscribe, like, and click on the notification button for more updates. Follow us on Facebook page at Mathematics Simplified. Evaluate tan square 30 plus cos 60 without using table. In order to calculate our tan 30 and our cos 60, we have to use a special angle from our equilateral triangle to calculate tan 30 and 60. For more videos on trigonometry, check out our playlist on trigonometry for better understanding on trigonometrical ratios. Alright, diving into this question, if we have a triangle, half section of our right angle triangle, of our equilateral triangle, where we have our hypotenuse as 2, adjacent as 1, and our opposite as root 3. Okay, now tan 30, considering angle 30, will be opposite over adjacent. Now, for 30, our adjacent is 3 and our opposite is 1. So this gives us 1 over root 3. Now, for cos 60 is adjacent over hypotenuse. Now, for cos 60, our adjacent is 1 and our hypotenuse is 2. Okay, now coming into this, imputing our values for here, tan 30 is 1 over root 3 all squared plus cos 60 1 over 2. Okay, using this square to open up this bracket, this becomes 1 over 3 plus 1 over 2. So this will give us LCM will be 6, 2 plus 3, which will give us 5 over 6 as our answer. So the value of tan squared 30 plus cos 60 will be 5 over 6. Now, in this diagram, they said our AC, line AC is 12 cm, angle ACB is 60 degrees. Now, we should find the value of X without tables. Now, from here, we know that we are looking for opposites. Alright? Since we are looking for opposites and we have hypotenuse, we know that in a SOHCAHTOA, okay, we have opposite and hypotenuse, which we are looking for opposite and our hypotenuse. So from here, we can now say sine 60 equals x over 12, since we are talking of opposite over hypotenuse. Now, so our x will become 12 times sine 60. Now, since they said without using tables, okay, without using tables, that means they expect us to use a special angle theory in calculating sine 60. Now, looking at our special angle table, okay, 60, 2 and 1, root 3, okay, sine 60, which is opposite over hypotenuse, will become opposite of sine 60 here is root 3 over hypotenuse, which is 2. Okay, so now imputing the value of sine 60 there as root 3 over 2 here, this gives us x equals to 12 times root 3 over 2, which is our sine 60. So this here 1, this here 6. Our x will give us 6 root 3 as our answer. So our answer will become 6 root 3 centimeters. Without using table, find the value of sine 60 plus tan 45 divided by sine 60 minus tan 45. Now we have to calculate our sine 60. Alright, this is 2, 1, root 3, 60, and 30. Now, since we are considering sine 60 is opposite over hypotenuse. Sine 60 equals opposite over our hypotenuse. Now, opposite is root 3 over our hypotenuse, which is 2. Now, for tan 45, 1, 1, root 2. Now, tan 45 is opposite over adjacent. So, our opposite is 1, adjacent is 1. So, our tan 45 is 1. Okay? Now, so now coming back to our question that says solve sine, this will become root 3 over 2 plus 1 all over root 3 over 2 minus 1. Okay, now in doing this, we will now find our LCM for both numerator and denominator. Our LCM here will be 2. This becomes 3 into 2, 1, root 3 plus 2. Okay, all over LCM here is 2. This becomes root 3 minus 2. So here we are having it as 2 root 3. Okay, 2 root 3 plus 2 over 2 root 3 plus 2 over 2 all over root 3 minus 2 over 2. So if we do the inverse, this becomes root 3 plus 2 all over 2 times 2 over root 3 minus 2. So this cancels out, leaving us with root 3 plus 2 all over root 3 minus 2. Okay, now from here we can rationalize our question. Okay, if we rationalize our question, our answer here, from here, if we rationalize this, we are going to have root 3 plus 2 all over root 3 minus 2 times root 3 plus 2 all over root 3 plus 2. Now, in rationalizing, we use the conjugate of our denominator to rationalize. Alright, and to get your conjugate is to do the opposite of the sign you have here. Since this is minus, we use plus. So from here, we are now going to have 3 times root 3 times root 3 will give us 3. Root 3 times 2 will give us plus 2 root 3 plus 2 root 3 plus 4. 2 times 2 will give us 4. All over, this will give us 3 plus 2 root 3 minus 2 root 3 minus 4. Okay, so this will cancel out, leaving us with 3 plus 4 root 3 plus 4 all over 3 minus 4. Okay, so from here, we can now say this to be 4 plus 3 will give us 7 plus 4 root 3 all over 3 minus this minus 1. So multiplying all through by minus to eliminate this minus, this becomes minus 7 plus 4 root 3 all over 1. Okay, so if you open up this bracket, this becomes minus 7 minus 4 root 3 over 1. So that forms our answer for sine 60 plus tan 45 all over sine 60 minus tan 45. If cos theta equals 12 over 13, find 1 minus cos squared theta. And 2, if tan theta equals 3, find the value of sine theta times cos 90 minus theta. Now it's important to remember that our cot theta equals 1 over tan theta, and tan theta equals opposite over adjacent. Now, in solving this, we know that cos theta, okay, our solution for question 1, we know that cos theta equals adjacent over hypotenuse. So here we've been told that our adjacent is 12 and the hypotenuse is 13. Okay, in doing this, we need to find our opposite, since tan theta is opposite over adjacent. So if we find our opposite, okay, 13, 12, and x. So this becomes 13 squared minus 12 squared equals x squared. And 13 squared is 169. 12 squared is 144 equals x squared. So this will give us 25 for x squared. So our x equals 5, which is our opposite. So if opposite is 5, we can now find tan theta. So our tan theta equals 5 opposite over adjacent. 5 over 12 will be our tan theta. So therefore, cot theta equals 1 over 5 over 12, which will give us 12 over 5 as cot theta. Okay, so our cot theta equals 12 over 5. Now, since they say we should find 1 minus this becomes 1 minus cot squared theta will become 1 minus 12 over 5 squared. Okay, so from here we know that 1 minus 12 over 5, 1 minus 12 squared is 144 all over 25. Okay, so our LCM here will become 25. This becomes 25 minus 144. Okay, 25 minus 144 will give us minus 119 over 25. So minus 119 divided by 25 will give us minus 4.76 as our answer. Alright, now to question 2. It says if tan theta equals 3, find the value of sin theta cos theta. Now looking at our tan theta, we know that tan theta is opposite over hypotenuse. So now, since we know that tan theta is opposite over hypotenuse and they say is equals to 3, that means our tan theta equals 3 over 1, which will give you 3. So our opposite is 3, adjacent is 1. So if we have a triangle where our opposite is 3, let's call this theta, okay, and this should be 90 minus theta. So our opposite here is 3, adjacent is 1. So we can find our hypotenuse. Our hypotenuse will become 3 squared plus 1 squared, which is 10, which is going to be 10. So our hypotenuse will be root of 10. Okay, and square root of 10 is giving us 3.162. Okay, all right. Now, in doing this, sin theta equals opposite over hypotenuse. Now, our opposite, sin theta opposite, will become 3 over root 10, which is a hypotenuse, and cos 90 minus theta will give us, cos is adjacent over hypotenuse. Cos will give us adjacent 3 over root 10. Now, since we are multiplying them, this becomes sin theta times cos 90 minus theta. Okay, now how do we get this? Considering our angle here, 90 minus theta, this becomes our adjacent. Considering theta, this becomes our adjacent, while this is our opposite. Now, sin theta will give us 3 over 10, sorry, 3 over root 10 times 3 over root 10. This will give us 3 times 3, 9, all over 10 times root 10 times root 10, 10. So our answer will become 9 over root 10, or 0.9 will give us our answer for sin theta times cos 90 minus theta. With this, we've come to the end of today's tutorial. Don't forget to like, subscribe, and click on the notification buttons for more updates.